Question 9 asks me to calculate a class width and class boundaries. So what I need to do for my class width equation is I need to take the maximum minus the minimum divided by the number of classes. The maximum in this case, 136.8, minus the minimum, 65.5, divided by the number of classes, 6. The number of measurements doesn't enter into the calculation. They're going to give it to you, but really it's there as a distractor. When I do this in my calculator, 136.8 minus 65.5 divided by 6. This gives me 11.88. I'm going to round that. So in the question, I'm going to see if they tell me how they want it to be rounded. It looks like they say enter as a common separated list. Use the minimum value. Round class width to the nearest multiple of 3. So since it says nearest multiple of 3, we got this to be 11.88. That's why we're going to call this 12. Our class width is going to equal 12, and we need to know where to start. So we need to start at the nearest multiple of 3 that's less than the minimum. So I'm going to start this at 63. From 63, I'm going to add 12 to get to 75. Plus 12 is going to get me to 87. Plus 12 is going to get me to 99. Plus 12 is going to get me to 111. Plus 12 is going to get me to 123. Plus 12 is going to get me to 135. Since our max is greater than that 135, we're going to have to go one more. So that's going to give me 147. If I was looking at the classes, 1, 2, 3, 4, 5, 6 classes. So maybe that doesn't get it done. Perhaps they want you to start at 64 so that this one's included. It's a little tricky. Honestly, look at what it says as an answer here. I think it's going to be close to that. I'm not sure if they want you just to start at 65 and go by 12s from 65. That actually makes a little more sense. So if I go 65, I'll just put everything up 2. So that's 7, that's 9. This becomes 101. This becomes 113. This becomes 125, and that becomes 137. Once it's 137, it does include all of the numbers here. For number 10, they ask me what proportion of measurements are less than 2. They do say to make a relative frequency histogram from the information. It'd be wonderful if you did that. It would be helpful. You could go through all the steps and get the proportion. But really, for what the question's asking, I can just count how many numbers there are, count how many of them are less than 2, and that division will give me the proportion without having to do all of the relative frequency steps. So, what proportion of the measurements are less than 2? Well, that's everything that I have except the ones that are 2s. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 total measurements. My proportion is going to be out of 20. Of those, the ones that are less than 2 are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the proportion of measurements less than 2 is 15 out of 20. Or if I want that as a decimal for my calculator, that should tell me 0.75. I also could have done this by just subtracting out the ones that were 2s. So there's 5 2s. If there's 20 measurements and 5 of them are 2s, that means 15 of them are not 2s. That said, the overall calculation is proportion that fit what I'm looking for, things less than 2, over total number in the data set. Number 11 says consider the following data set. I have n equals 8 measurements. Here they are arranged in random order. Since I'm going to be calculating the mean, median, and mode, my brain should say, let's put these numbers in order before we get started. So I see the smallest number is 3, then I have 2 4s, 2 5s, 2 6s, and a 7. I always want to double check that I have all the numbers, so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. I do have all the numbers. I can now calculate the mean. For the mean, we're just adding all of the numbers together. So 3 plus 4 plus 4 plus 5 plus 5 plus 6 plus 6 plus 7. If I total them all up, I get 40 out of the 8 numbers that I had, which means the mean is 5. When I go to calculate the median, I'm going to use my position function. The position of the median equals n plus 1 over 2. In this case, I have 8 data points, so it's 8 plus 1 over 2, or 9 over 2, which is 4.5. What that tells me is it's located between the 4th and 5th data point. If I count over 1, 2, 3, 4, here's the 4th. The one after that is the 5th. Since they're the same, I could really stop here and just report the median as 5. Technically, though, the median equals these 2 data points, 5 plus 5, divided by 2. That gives me 10 over 2, or 5. So both the mean is 5 and the median is 5. When I go to calculate the mode, here I have 3 different numbers listed twice. All of them count as the mode. So I'd write this as 4, 5, and 6. This is an example of a multimodal distribution because there's more than 2 modes. When it now asks me to locate these measures on a dot plot, I can draw on my scale every number that I have. So 3, 4, 5, 6, and 7. Only 1 dot above 3, only 1 dot above 7, and then 2 dots over the 4, the 5, and the 6. I would write that my mean, my median are here. Really, I could write mode, mode, mode. So this would be the general dot plot that I'd want to select from the available choices.